Spark Foundation Day 1. As a part of our efforts to build out data engineers for tomorrow, I am going to start a couple of playlists. One of that playlist is going to be Spark Foundation for data engineers. I'll be posting around 21 videos for Spark, which covers all the basic learning of Spark. So this is a day 1 and first video. In this, I wanted to take a high level topic of from Hadoop to Spark 4.0. How from Hadoop we as a data engineer moved to Spark. When I started my journey in a big data almost 15 years ago, the word Hadoop was everywhere. Everyone was using Hadoop. Every organization wanted to process huge volumes of data, and Hadoop MapReduce was way to do it. There was no other way. Otherwise, you need to have a larger warehouses, marts, and the way to process was to have paid licensing cost and all, right? So then came the idea that we could do all these things with just a commodity hardware, and for that Hadoop came into picture. Okay. If you ask me today, very few engineers still write the MapReduce. So when we see around, MapReduce is like almost on a decline. There is hardly a new MapReduce program being written. Uh, I think MapReduce, if any at all exist, they are on the verge of getting converted to Spark. So instead, almost everywhere we see Apache Spark. And even recently, a 4.0 Spark 4.0 has been released. So the main question is, why did Spark replace MapReduce or Hadoop as an engine for big data processing? In order to understand this, we must understand few things. Okay. So first thing is data processing on a single machine. So let's say you are processing a file. The size of the file may be, let's say, uh, a 20 kb or 20 MB file is there, and you want to process it on your machine. It is quite simple, right? You just write a program, and your machine CPU is more than sufficient to process the size of a file. When the size expands beyond a point where your machine CPU is not capable of catering to that processing, then comes the idea that you can't process it here, you need some systems. And that's where the Hadoop came into picture. What idea Hadoop brought in is you can process it by splitting the data into multiple chunks and then processing it on the commodity hardware. So they built something like master slave architecture, in which master was a driver program and master used to drive uh, this splitting of the file, pushing it to multiple servers, and then collecting the result back. So this type of distributed processing is brought by Hadoop. The major idea behind Hadoop was like processing it on the distributed commodity hardware. Correct. So this word is important: distributed commodity hardware. And people used to like quite a complex program. Even to do a smaller or simple operation, you have to write a huge amount of map and reduce type of program and all these things in Java. So Hadoop was a brilliant idea for its time. Before Hadoop, data was too big to process on a single server. So therefore, as I mentioned, Hadoop introduced something called distributed computing. It also introduced another concept called distributed storage, where we break the files into blocks and spread them across the machines. So even data was distributed across multiple machines, and similarly, even the compute was distributed. So data was called HDFS, something called Hadoop Distributed File System. So splitting a huge file into multiple Hadoop distributed file system, and then even splitting the compute, that is map and reduce. So this was the time when we were processing some terabytes of data, right? Like terabytes of data started getting processed. But one of the main pain point of Hadoop systems were they were very slow in the processing, because since it was on the commodity hardware, it was having a high probability that the commodity hardware could fail. If fails, then Hadoop used to recalculate everything, and that would take time. And second point was each and every time Hadoop used to write the things back to the disk. Okay, so the since it's a commodity hardware, the memory in memory or the processing memory is very small, and therefore it has to write everything back to the disk. So let's say a particular the commodity hardware is processing like 100 MB of a file. So it would have to process it, and if the memory is not sufficient, it would write it back to the disk. So disk write also would add a overall time. So overall MapReduce process was very slow, and every step used to be a pain, and therefore jobs used to run for days, like 1 or 2 days job used to run sometime. Even I have heard that Google's analytical job used to run for days together, continuously generating different analytical points and all. But then there came the uh, superhero, right? Like this pain point has to be addressed. So Spark came into picture. What Spark brought in is uh, huge in-memory processing or in-memory computing. So we moved from disk-based computing to in-memory computing. Okay, so Spark introduced something called a driver program, and driver program used to work with worker nodes, driver and worker. So these are the concepts of Spark. Like driver is something that is going to drive how the entire processing works, and worker is something that is going to distribute and complete the work. Okay, so this is the Spark architecture. And another thing which it brought it with is the size of a worker node. They use the in-memory size of the processing memory size of the worker node used to be huge, and therefore it would help uh, in-memory processing and would minimize the disk write time. Okay, so all these two problems were addressed, and because of that, the processing speed increased. So processing speed increased from, let's say, days to couple of hours or few minutes. Then came the Spark, right? So UC Berkeley is where the Spark is born. Spark looked at Hadoop problems and asked, what if we could keep the data in memory instead of writing it back to disk every time? And therefore Spark was introduced. In my next subsequent lectures, I'll put the different concepts of RDD, data frame, and data set. But just to introduce this, Spark brought in a new concept called RDD, Resilient Distributed Dataset. A dataset in which the file will be split and spread across multiple cluster for storage and processing. But a data set would be there which will take care of this, and that data set is called RDD, Resilient Distributed Data Set. All three words are very important. Resilient because it is running on commodity hardware, so if anytime it fails, it has all the trace history, it will quickly recalculate itself. And since everything is in memory, the speed is faster, so that is resilience. Distributed, since the data set is distributed across multiple compute machine, therefore distributed. And dataset is dataset. So that's where it's a JVM objects basically. So JVM objects, that's why it used to be called a dataset. And that's exactly what Spark did. It introduced something called resilient distributed dataset, which allowed data to be cached in memory and reused across steps. So suddenly the speed of the processing increased, and the task that I mentioned, right? Hadoop used to take hours to complete. It could be done in minutes, and therefore Spark became a popular choice for all the data engineering aspirants. And even over the time, Spark has introduced multiple things. It has innovated like anything, and therefore Spark SQL, a dedicated SQL querying engine, Spark Streaming, something for real-time data, machine learning libraries for large-scale machine learning computing, and GraphX for graphical analytics. So these type of libraries started coming into Spark. Recently, Spark 4.0 has been introduced. It's a huge advancement over the previous version of Spark, and it has multiple things, right? Like adaptive query execution. So Spark can optimize queries dynamically. So whatever the querying that happens inside the cluster, Spark has its capability to optimize it. It has Delta Lake integration. So Delta Lake has been one of the popular way to store the data over the data lake, and therefore uh, Delta Lake integration, a complete Delta Lake integration, serverless execution, um, better Python APIs, all these came into being as a part of Spark 4.0. And therefore, Spark isn't just a Hadoop, it isn't just a faster Hadoop, it's a data engineering platform that powers everything from batch to real time to even machine learning model training. So, because of all these new features, popularity, Spark has grown into the framework of choice. Until now, there is no uh, other framework available which is challenging the Spark hegemony. Now then, just quickly going through why Spark is the engine of modern data pipeline. Because let's think of role of a data engineer today. So if what data engineer do is he ingest raw data, transform and clean and aggregate and prepare the data. Spark allows you to do all of this in a single unified framework. Unified is the keyword. It allows everything in a single unified framework. You can read files, clean missing data, join, calculate, and save the final output with just simple Spark APIs. Okay, so you just use Spark APIs, resilient data, distributed data set, and internally it would take care of everything. So that's what we wanted, right? So earlier in Hadoop days, we have to define that, okay, on which cluster it will be, how it will be managed, what is the size and other things. But here in case of a Spark, internally it does lot of things. So optimization and all are like inbuilt. A quick demo, like for example, as you can check MapReduce code, it's a few files of code that we have to write to do a simple sort of an operation. But a quick demo of what Spark code looks like is, this is like 4 to 5 lines of code internally. You just give the location of the file, you just build out a Spark session. This is a very important lecture on Spark session. I'll just give that in the subsequent video. So here you can see it is building the Spark session. It is just reading the file. So while reading the file, you just have to give a path. Internally, Spark will decide how to read the file, where the file is present, how to split, how to efficiently read and all. Everything will be taken care internally. And then you can see quickly, you can do a show and group by, right? So even without knowing much Sparkit, you can see how clean and expressive this code looks, correct? Summarizing, Hadoop laid the foundation, but MapReduce was slow and clunky. Spark solved that by keeping data in a memory and offering a unified platform. Spark 4.0 is now a backbone of modern data engineering, fast, scalable, and friendly to Python developers. As a freshers, your journey with Spark is just starting. In the coming days, we'll go deeper into Python Essential, Spark data frame, transformation, optimization, everything done in a very clean way compared to what Hadoop used to be. But keeping today's story in mind, Spark became dominant because it made data simple, faster, and practical. Tomorrow we'll roll up our sleeves and begin with Python basics that are needed for only for Spark. There is a separate video series that I'll start for Python Foundation. Okay, only learning Python for data engineering. But I just wanted to keep one lecture on PySpark because we'll be learning everything on PySpark. Okay, so that's a day one, and thank you for listening in and joining in. Please do provide your feedback, and please do subscribe to listen into these 21 articles on Spark. The idea is if the fresher aspirant go through these articles, he should be able to learn, appreciate Spark quickly. Okay, thanks a lot, guys. Thank you.